Hey everyone, and welcome. Today, we're going to dive into something really cool. It's a theory that tries to build our entire universe. Yep, everything from tiny particles to gravity itself, all from one single, incredibly simple idea. So let's get right into it. So let me ask you this. What if everything you see, everything you are, and all the forces holding it all together could be explained by just one fundamental material? That is the absolutely mind-bending question at the heart of what this source material calls Theory 7. It's a really bold shot at a theory of everything. Now, the hero of this story, if you will, is a concept called the ether. And look, forget anything you might have heard about the ether before. In this model, the ether is the literal fabric of existence, and it is not empty, not at all. It is filled with a constant chaotic storm of sound waves. And these waves, they're not just some background noise. They are the actual building blocks of everything. Okay, so if everything is just sound waves rippling through this ether, where do really fundamental things like space and time even come from? In this first section, let's see how this theory builds the very stage that the universe plays out on.
You know, the logic here is actually super elegant. Think about it. A wave over here can't just instantly affect a wave way over there. Its influence has to travel across the ether. And according to the theory, it travels at a constant maximum speed. This universal speed limit forces space and time to become tangled up with each other. Because if speed is constant, then time itself has to stretch and shrink depending on how you're moving. And boom, just like that, you get Einstein's space-time, all from the simple idea that waves just take time to travel. All right, so we've got space-time, and it's built from waves. But what about the stuff in the universe? You know, the solid, tangible particles like electrons. Where do they come from if everything is just a vibration?
Well, the theory's answer is just beautifully simple. A particle isn't some tiny solid ball. No, it's what the source calls a wave packet, basically a concentrated knot or lump of wave energy. And from far away, this little lump of energy behaves exactly like we'd expect a particle to. It moves in a straight line, it has a specific speed, it's a particle.
And this is where it gets really cool, because this brilliantly explains one of the biggest mysteries in all of physics, right? Why do particles on the quantum level act so weird, seeming to be in multiple places at once? Well, if a particle is actually a spread-out wave, that's not weird at all. It's just its fundamental nature. All that strangeness of quantum mechanics just becomes a natural, expected consequence of this wave-based reality.
So what gives these wave packets their different personalities? Well, it starts with mass. In this theory, mass isn't about stuff. It's not a measure of how much material is there. Instead, it's a property of the vibration itself. A wave with mass is one that can vibrate at a higher frequency than its wavelength would normally allow. We see that excess frequency as mass.
The second key property is spin. Now, this has to do with the wave's polarization. Basically, the direction it's vibrating. Is it up and down, side to side, circular? Spin describes how that direction of vibration seems to change as you rotate your point of view around the wave. It's a really fundamental way of sorting these wave packets into different categories.
Okay, so now we have our basic ingredients, mass and spin. With these, we can actually start to build a symphony. Let's see how these simple rules allow the ether to create the two fundamental types of particles that make up our entire universe, matter and forces.
And right here, this is the great divide. You've got particles of matter, like electrons, which are called fermions. They have a spin of 1/2. Then you've got the force-carrying particles, like photons of light. Those are called bosons, and they have a spin of 1. And this little difference in spin totally changes their behavior. If you swap two identical fermions, their probabilities subtract, which is why two electrons can't be in the exact same state. But if you swap two bosons, their probabilities add together, which lets them all pile on top of each other.
Here's another key piece of the puzzle. The energy in these sound waves isn't continuous. It comes in these tiny, indivisible packets called quanta. And the theory makes a really simple, powerful statement. Every single quantum is a particle. The smallest possible bit of a matter wave is an electron. The smallest bit of a light wave is a photon. That's it.
Okay, so we're ready. Let's take an inventory of the particle zoo. We know particles are just wave packets with mass and spin, but what decides how they interact with each other? Well, the answer is charges.
This table lays it all out beautifully. You've got three fundamental types of charge. There's the electric charge we all know, felt by electrons and quarks, and its force is carried by the photon. Then you've got flavor and color charges, which are a little more exotic. Flavor is tied to the weak nuclear force, carried by the W and Z bosons, and color is the charge for the strong nuclear force, carried by gluons.
But the details here are where it gets super interesting. Quarks are special because they have all three types of charge. Leptons, like our friend the electron, are color neutral, which is why they don't get trapped inside the nucleus of an atom. And get this last point. Unlike the photon, the carriers of the weak and strong forces, the W, Z, and gluon bosons, can actually interact with themselves. That makes for some way more complex physics.
And then there's the outlier, the Higgs boson. This one's unique. It's got spin 0, and it doesn't carry a force like the others do. Nope, its job is to interact with other particles to give them that excess frequency property we talked about, what we feel and measure as mass.
So we've built particles, forces, and mass, all from sound waves. But there is one giant glaring force left over. So let's move to the final and honestly, the most radical part of this theory, its explanation for gravity.
So, you'd think there would be a particle for gravity, right? A graviton? Well, this theory's most crucial point comes from a direct quote in the source material. It makes a pretty shocking claim: gravitons do not exist. The argument is that we've already used up all the possible ways for the ether to vibrate when we made the other particles. There's nothing left for gravity.
Okay, so wait a minute. This is the big question, right? If there's no force-carrying particle being exchanged, then what in the world is pulling you down to your chair right now? What's keeping the Earth orbiting the Sun? The theory's answer isn't about a particle at all. It's about the ether itself.
So here's how it works. The ether isn't static. It acts like a fluid. And all those sound waves, all the matter and energy in the universe, they create pressure in that fluid. Where you have a lot of energy, like in a star or a planet, it actually creates a low-pressure zone. This pressure difference causes the surrounding ether fluid to flow inward towards that concentration of energy. And that large-scale flow, the actual movement of the fabric of space, that is what we experience as gravity.
And this model gives us an amazing picture of a black hole. What is an event horizon? In this theory, it's simply the point where the ether itself is flowing inward faster than the speed of sound within it, which, remember, is what we call the speed of light. Anything caught in that cosmic current, even light itself, just can't escape. It's like being swept past the point of no return in a river.
This slide just perfectly sums up the whole shift in perspective. You've probably heard Einstein's famous line, "Matter tells space-time how to curve, and space-time tells matter how to move." Well, this theory proposes its own version. Sound waves tell the ether how to flow, and the ether tells the sound waves how to vibrate. It's a dynamic, fluid, mechanical universe.
And that is where the source material leaves us, with a completely radical new picture of the cosmos, from the tiniest quantum vibration to the grand, sweeping flow of gravity. All of it born from simple sound waves in a single, universal ether. It's a compelling idea for sure, and a question worth pondering. Could reality really be nothing more than a cosmic symphony?